Okay, hello. This is superlinux.net. This is Rani Ahmed with you. This is an application demo for Android. It's called General Engineering. The aim of this application is just to consolidate as much as as much as we can of engineering formulas and physics formulas into one application, and give them the suitable forms, so the engineer or the scientists of physics can use the forms to fill the data, so he can get the values he wants without going into the hassles of the calculator would be a little bit cumbersome. So just having a form to fill in and then get the value of the thing that the physician or the engineer would like to find, and he will find it easily. I'm going to start one by one here and tell you what each one is all about. Now, here I have, and I start with the units table. The units table is just a listing of all units. Okay, and here's everything about it. Okay, it's just everything about units. Okay, in general, and their abbreviations. Now, also, I want to jump to the physical constants first, because it's just similar in the way it's displayed. So we have here a relative density table of many constants, and here we have the universal constants, and you can still zoom in and zoom out just to have a better reading. Okay, so here I'm using the simulator or the emulator of Android, so to give you what will happen if you have a real device. I'm just here using my emulator because I need to record this video for you. And then now I have like units conversion. So this tool is just to convert units. I have this list of conversions, like A to B and B to A conversions all the time. Okay, so from Fahrenheit to Celsius, and Celsius to Fahrenheit, and acre to feet, and feet to acre, and everything, like from the start to the end, and the opposite way, from end to start. Okay, so you can have as much as you want of conversions, and it's known that if you put minus 40 for the Fahrenheit, you must get minus 40 for the Celsius. Okay, they meet on minus 40. Okay, and you can test anything else, maybe from meter square to feet square. Okay, now the negative is just something because you need it with Celsius. Okay, I have here around 100 conversions. Okay, if you sum all those. Okay, now, so this is how much I want to convert from meter square to feet square, and I get the conversion value in feet square. Now, Next, I have here in the applied math for engineers, like first I start with the geometry. Okay, I have the area and volume of like the standard shapes: rectangle, triangle, circle, trapezoid, rectangular solid, and a cone, pyramid, prism, sphere, and cylinder. Okay, and I mean, there are for the formulas are written for you, so you can see them also. Okay, they are on the bottom. It's just here they are very small. Okay, but it's just the width by the length for the rectangle. I don't want to go through it so much. Okay, it's very clear. Here's for the sphere, here's for the cylinder. Okay, here you have a trapezium. Okay, now I have here also about significant locations of the centroid, and you know, I want to find the location of a centroid and a triangle and a quadrants or semicircles, okay, or in a part of a parabola, okay, or in arcs. This is all about centroids. Here I have the nth degree equations, like you want to find the roots of polynomial. We've made the second, the third, and the fourth, and the fifth degrees. Okay, so I have here, it's rotated. Okay, so you can read the whole formula. You put here the coefficients a and b and c. So if I put like 2 and 1, I just say solve it and you get two values. Put 2 here. Okay, you get also complex values. And here I have for the third degree. I don't want to rotate it every time, it's very clear, so you get it like third over here. Okay, same. This is for the fourth. See the fourth degree here. This is for the fifth degree. Okay, now you can put the input here as a negative for the coefficients. Okay, so you will, once you read it, something like -1, 2, okay, and 3, and maybe 5, 2, and 4. So it'll solve it and it will give you one real root over here, and the rest are complex roots. Okay, now I'm going to rotate it. And then I have the electrical engineering, you know, covering as much as we can of topics. Here I have the Ohm's law, and just select, for example, I want to find the power in watts. So using which of the following, like using intensity and resistance, or using voltage and intensity, and using voltage and resistance, and however you change it, it will change the requirements. And if you change here, for example, you want to find the intensity or the voltage or the resistance, okay, just to find the other fellows in the formula of Ohm's law. No. Next, I have here the resultant sum, okay, of resistances or inductances or capacitors. So I have I select what kind of sum I want. Okay, if I want capacitors, it will change to capacitors. If I want to have inductances, I will have inductances, and I just select the number of elements. You can have from 2 up to 10 only, and 10 is like enough, more than enough to have such a sum. And here, for example, if you want to have resistances in parallel, you can do a parallel. Okay, and then of course you can, like, if I type here 5, if I skip, for example, here someone, if you ask, it will tell you some element is missing. Okay, so and you can also reset the whole form. Okay, then start from again. Now here I have the motor windings. Okay, you know, the motor, as it rotates, it builds up heat, and therefore the resistance changes. The resistance of the windings change, okay, inside the electrical motor. So here I do a correction of the resistance value on the temperature after the resistance got heated. Okay, and therefore later you can use this value just to calculate the exact power used in the circuit. Okay, and the formula is written for you here. Now here it's all about the voltage drop. You select the type of the phase and the type of the voltage and the type of the cable. Okay, and therefore you get the minimum wire size required. Here it's about resistance color code. So the multipliers, you should just set the multipliers, and you will get the value of the resistance. Okay, and it's defined which one is digit 1, which one is digit 2, and which one is the multiplier, and you will know that in the program. Okay, now here it's about Wheatstone bridge. Just fill in the blanks. What's the input voltage, what are the resistances in the bridge over here, and you get the resistance, the missing resistance. Okay, and here I have about low pass filters. Okay, I can just like, you know, find the LC and the LNC accordingly. Okay, this is about high pass filters. Butterworth has high pass filters. This is about Chybeshev. This is low pass, and this is high pass filter. Okay, this is also equal component pass filters, low and high. Now I have here about the pi attenuator. I have here about the T attenuator. I have here about the helix antenna design. Here I have about the battery life. Calculate your battery life. Here I have about the BJT transistor bias voltage. You calculate for that. Here I have about the non-inverting operational amplifier resistance. Okay. Then I have the last thing. I have the Zener Diode. Okay. Calculate the Zener Diode voltage. Okay. And the radar change. This is for electricity. Okay. Now, in mechanical engineering, I have a calculation of the resultant sum of two forces. So you have here 10, 10, and maybe you have degree is 60 between F1 and F2, and when you calculate it, it will give you this the size and the sign of the angle, okay, between R and F1. Okay. And if you have it something like 180, it will also give you that the angle is 0 between R and F1, and because they are equal. Okay, so if you have like something like 11, it will give you that it is -1. This is about the gravitational acceleration. You can manually enter the altitude of your location from the sea level, okay, and therefore you can find the G. So if I have it as 0, let's try here. Okay, so I find the G in image G is 9.8, you know, yada yada yada. But here I can also use the GPS to get the altitude, and also use the GPS to get the latitude and the altitude, and the latitude and the altitude would vary the value, okay, of G, and it's good to show it to your students. Okay, at school. Maybe take them on a trip, and will help them see that change, maybe to the mountains once or twice. Okay. Here it's about finding the bending in a rectangular beam, whether it's hollow or solid, okay, and for different types of material. Okay. Also I have here for the round beam, same thing, hollow, solid, and for different materials also. Now I have here about screws, the internal thread. You calculate that it's shear thread, okay, shear area thread, I mean. Okay. I have here the threads per I mean this thread shear area also for an external screw thread. Okay. And here I have the cam profile with follower, so it will draw the profile of a cam rotating across or about a cam, that there is a rotating shaft holding the cam to rotate the cam, and this piston is, or the follower, what they call also the follower, will move up and down according to the shape of this cam. Okay, but this cam is like it doesn't have to be like an egg or like an ellipse. Okay, it can be of any shape. You may find something like shapes which are like illogical. So I'm going to select all the default values. So I can start with basic radius here of 1 meter, offset is 0, follower radius is 0.01. okay, here's like maximum lift is just like 0.1, 3000 for the RPM. Those must be 180, sorry. No, I mean it's a full circle, so it's 360, sorry. So I have memorized those numbers. Okay, now those are for the parabolic. They won't work unless you choose a parabolic. Okay, you can't fill them unless you have a parabolic motion. Okay, here's the parabolic motion. Okay, so I must start with finding the cam profile coordinates. So I can, I give you a chance before plotting it, just to give you the data, okay, for all the 360 points, okay, around the clock, around the whole circle, and then press OK, and then I can plot the profile. I just have to wait. Okay, and this green line constitutes the cam. Okay, so you'll have something similar to bat like cam. So like the follower will scroll all over the and move on the green line. Okay, and when it reaches this point, it will like fall suddenly over here and just move again, so it will rotate this way. Okay, so I hope you like this software. Okay, please more comments on this and enjoy. Okay, rate this application. Bye.